So piecewise practice, again, can be done two ways depending on what you're trying to find. We're going to start with the algebra way, which is basically substitution. And then from there, we're going to start doing it graphically. So I'm going to show you several ways to be able to do this. But whenever we're doing any of these, the first thing I have to peek at is this if part. Because this part is going to let me know which expression to use. And I'll warn you throughout this, I'll be changing the zoom on this depending on what we're doing so you can see a little bit easier with some of it. But what I'm going to be doing is I'm going to be looking at those values 1 through 5 listed below for x. And I'm going to use those values in these inequalities to see which one is it true for, because it's never going to be true for both. It's only going to be true for one. So for instance here, if I take my 10 and I plug it into the top one, is 10 less than or equal to 4?
Are you asking?
Yes. It's not. No, 10 isn't less than 4.
No.
But is 10 greater than 4?
Yeah.
It sure is.
Yes.
So when you're doing that, that tells me this is the expression I'm going to use. So all I'm going to do is I'm going to take this and I'm going to plug the x value into it. And then, of course, simplify it and find the answer. But you cannot just go through and say, well, I'll just do both for everyone, and one of them will be right. It doesn't quite work that way. It's only going to work for the one that's true for my if statement.
Could you zoom in a little?
I can give it a shot here. Let's see.
Thanks.
Okie doke.
That's better.
So that's what I'm going to be doing for all of these. I'm always going to take the x value they give me. So let's see here. Is negative 1/3 less than or equal to 4? Yeah, negative 1/3 is less than 4. So I'm going to be plugging into this top one this time. And again, it's just the x value that I'm plugging in. Now let's say fractions aren't necessarily friendly with you for some reason. Okay, and this is one of those things where we do what we need to get the job done. I can always do a little side work if I have to. I can take the whole number, turn it into a fraction if I need to. And then just multiply straight across. So even if I can figure out what it is, I still got to watch the details here on how to actually get to my solution. Could you punch that in the calculator? Sure. That would work too. But it's that first step that makes or breaks me on this and helps me determine which expression to plug into. What about number 3? What if I plug in 4 for x? Which one's that going to work for? Yeah, the top one, because it's got the or equal to. So again, it's one of those little things to watch. But again, all I have to do is plug it into that expression then that goes along with it and get my answer. So we're not trying to make things overly complex here. We just got to figure out which one it goes in, plug it in, we're done. And we're going to do the same thing below. So I want to kind of mix in some things and give us plenty of time to do the graphing, because that's where most of our focus is going to be today. Down below we got the same thing working, except I have multiple functions we can plug into. So now I got to pay attention to what letter is in front. So when I'm doing this, for instance, you'll notice on 1 through 4 they all have f's in the front. So for 1 through 4 we'd use f of x. 5 through 8 they all have a g in front. We'd use g of x. Okay? And then those last 3 all have h of x. So we'd get those 3 in for that. But otherwise this works the same, except for one very strange thing about f of x, which we'll find out here in just a second. There's my if. Always got to do that first. So you're like, wait a minute, I don't see x equals anywhere. Whatever value is inside the parentheses, that's always my x value. So here I'm testing out x equals 2. Top or bottom, which of my two inequalities does positive 2 fit into? bottom because 2 is greater than 0. You're like, okay, so I'll plug 2 in. Wait a minute, there's nowhere to plug it in. There's just a number here. Then I just write the number. If there's no place to plug your value in, so for 1 through 4, our answer is either going to be 2 or it's going to be 3 because there's nowhere to plug the x. And that's just going to be the way it is sometimes. And we'll get to see some pictures of that coming. So let's do one more in the F category here. -4, top or bottom? Oh, top. -4 is less than 0. So since there's nowhere to plug anything, I'll just use the 3 and go about my business. Oh, I got one more. I see it on the screen. Might as well do it. What about 3? Top, because of the or equal to, and so it's just 3. Now, am I going to get off that easy every time? Oh, no. Not every time. All right, so if we move to the G's, always look at the if first. We're not going to look at the F first? What? Okay. So if my x value is 7, top or bottom working for us? Okay. Bottom. 7 is greater than 3. Because remember, x being eaten by the arrow is greater. Pointing at x is less. So it's the bottom. So I just plug in the 7 where the x goes and simplify the expression. What about number 6? What about if x equals 0? Top. 0 is less than 3. So I just plug in a 0 there. Get my answer. Okay, keep life simple. I got one last one I want to do out of this section. Let's see if I can make this work. I want to do number 9, but my h isn't showing up. So, okay, we're going to remember that x is -4 here. If x is -4, which one does that go with? The top, because -4 is less than -2. Think about money. I do not want to owe $4. I would rather owe 2. We want the better situation in the greater than. So we're going to use the top. So 1/2 x minus 4. Swing back over here. So 1/2 x minus 4. Now again, even if fractions aren't your friend, I think we can handle this one without getting too fancy. Half of -4 is -2. And then I like to think about money. I owe somebody $2, I owe them 4 more. Now I owe them 6. Okay, I'd love it if I owed them 2 and owed them 4, and then they owed me 2. That'd be even better, but that's not the way the math works. So that's how we're going to do it algebraically. Use the if statement to figure out which expression, and then just plug your x value in. That's all we're doing for those. Now for the graphing, we're in for a treat, because I am going to show you not 1, not 2, but 3 ways you can try to tackle this. And I swear one of them has to work for everybody. So if one doesn't work for you, hang tight. We'll see if another one does. If you like the first way, I say just go for it. Just use it. Here's the kicker with number 1, though. You must use a pencil because we have to be able to erase. Well, I guess you have an erasable pen maybe, but we're just going to assume on these that you are okay with graphing lines. If you're not, take advantage of this to try and learn a little something with it. But otherwise, we'll give you some other options. So here's why I got to use a pencil. I'm going to be doing some erasing here. My first job is I'm going to graph this line, 2x minus 1. So remember, the number on the end is my y-intercept. So put a dot here. Then my slope, remember, if there's not a number underneath, we assume it's 1. So we're going to go up 2 and right 1. And I'm going to make as many dots as humanly possible going both directions. So once I run out of room going up, instead of going up and right, I can just go down and left, and I end up on the same line. Now, I don't want to connect the dots yet, because only part of this line is going to survive. How do you know which part of the line is going to survive? My if statement. The if statement says if x is less than or equal to 1. Less than, when I'm on a number line with x, means we want the points that are to the left. Oops, I don't want the word 2. The left of 1. In other words, I'm going to go to where 1 is. Okay, find my dot. And starting at that dot, I'm going to connect all the dots to the left of it. And only the dots to the left of it. What do I do with the rest of them? Erase them. And the only other thing I've got to remember with these when I'm doing them is what my end dot is going to look like. You're like, what do you mean? If I have or equal to, okay, or equal to, I'm going to have a closed dot because I can't do parentheses and brackets on these. It doesn't work. So for this one, we're going to have a nice big colored in dot. If I get one that's just no arrow, we're going to use open circles. So it's just a way for me to graphically show how this works. So I did it for one line, now I got to do it for the other one. Same process. Graph the line, so plot my y-intercept. My slope is 3 over 1. So up 3 and right 1, up 3 and right 1. Now, normally, I'd keep going and I'd start going down and left, down and left. But let's think about this for a minute. If x is greater than 1, which means I want the points to the right of 1, because that's where the x values get bigger. So let's see here. Here's x equals 1, bless you. There's my point. So I want an open circle, because there's no line underneath, and I'm going to connect the points to the right of that. And I have an extra point here that I don't need, and I'll get rid of it. That is the graph, the piecewise graph, of that particular function. Looks kind of weird, but that's how these work. So like I said, on the first two, we're just going to go with graphing lines and doing pieces. But here's the key. Wherever that number is in your if, that's where both of your lines have to start. I cannot start this one at -1 and this one at 1 at the intercepts. No, 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 no. I have people do that every year. You have to start them both at this point. You can graph the lines the other way, but the graph when you're done has to be there. So I'm going to do the same thing on the next one. 1/2 x. What's my y-intercept if I don't see anything on the end? 0. So my y-intercept's at 0. My slope is up 1 and right 2. And like we said before, we also can go down and left. But then the question, of course, is going to become what part survives and what part's going to go away at the eraser here. Okay, if x is less than 1, you're like, wait a minute, here's where x is 1. Harty, I don't have a point here. Now that's true, but I think we can eyeball this pretty well. So we're just going to make an open circle here that's kind of in line with those. And then less than is going to be our spots to the left of 1. Anything to the right of my big open circle, adios. And then I just do it one more time with the other one. My y-intercept's at +3. My slope is negative, or in other words, negative 1 over 1. So down 1, right 1, down 1, right 1. Here we go. I'm going to stop myself here and see where I'm heading. X is, whoops, we're moving and losing. Okay, there we go. X is greater than or equal to 1. We are heading to the right. So here's X is 1. Hey, I got a point this time even. And we'll connect the dots to the right, lose my other stray dot, and that would be our way of doing it, just by graphing lines and erasing. Okay, that's one way you can do these. Like I said, if you're good at graphing lines, I think this is the quickest and most straightforward way of doing it. But if you're not, all hope is not lost. We have more options. So we'll flip over to the back. We'll get our next option rolling here. And our next option, as we move back over and up here, is going to be the table option. So if we want to go the table option, we remember that f of x equals y. So here's what I can do if I go this route. So if I have the equation y equals x plus 2, I'm going to make a mini table here. I'm going to use 3 values. You'll never guess where the first one's going to come from. The if statement. That is where your first value, if you're going to do a table, comes from every time. If it's x is 2, you use 2. 3, whatever it is. It's just greater than. So I'm going to remind myself it's going to be an open circle there. And here's where I need your help. X is greater than 3. What are the next 2 values of x that are greater than 3? If you keep moving to the right on a number line after 3, what are the next 2 numbers? 4 and 5, okay. So those are the 3 values I'm going to plug in to get numbers out. 3 plus 2 is 5. 4 plus 2 is 6. 5 plus 2 is 7. And those are going to be the 3 coordinate points I use to make my line. So I go to 3, 5. Oh yeah, it's an open dot. I go to 4, 6 and make a point. I go to 5, 7 and make a point. Connect the dots from the big circle to the little ones. And then I just do the same thing with my other expression. Now, am I going to use the exact same numbers for x? No. Well, why not? The situation has changed. Right, we're still going to start at 3. We're still always going to start at whatever this value is. But right, since it's less than, if we're going left on the number line, I'd go to 2 and then I'd go to 1. Otherwise, it works the same way. 3 minus 3 is 0. 2 minus 3 is negative 1. 1 minus 3 is negative 2. But this time, because of the or equals, it's going to be a filled in dot. And I just do that on the chart to remind myself. So 3, 0, nice big filled in dot. 2, negative 1. 1, negative 2. And go from the big dot to the littles and connect the dots. Done. So even if those of you are just not graphing lines people, y'all can plug in a number and plot a point. I'm pretty sure. I have confidence in this. So we'll do one more like this just to make sure. Then I'll show you the calculator way. If you have a calculator as an option, then we can kind of look. So we'll find something that works for everybody. All right, let me switch back here. So this time, got y equals 2x. Where are we starting? We're starting at 1. They give us the first number every time. All right, so x is less than or equal to 1. Close dot. Less than. What are my next 2 numbers going to be? 0 and negative 1. All right. Then just plug them in. 2, 0, negative 2. So 1, 2, big dot, 0, 0, negative 1, negative 2. So we're down with 1. And then one last time here. So let's see, start at 1. What are my other two values going to be? 2 and 3. Now, some of you may be going, ew, fraction 2 and 3, fraction 1 and 3. Yeah, I don't like this. Play with the calculator, do some side work, do what you got to do. But here, open circle. Well, I know that 1 times 1/2 is 1/2. So 1/2 plus 2 is 2.5, or 2.5. Half of 2 is 1, plus 2 is 3. And half of 3 is 1.5, plus 2 is 3.5. And this is going to get a little bit squished, but that's okay. Because 1, 2.5, that's about here. And you may actually get some that overlaps sometimes a little. That's okay. 2, 3, 3, 3.5. Off to the right. So that's how our table method would work. 3 points is enough. It needs to be at least 3. 2 points, you can get yourself into too much trouble. All right, last option. And this is if you have a graphing calculator available. And like I said, I've still got that thing on the front of my website. If you've got a computer at home, you can get the same one that I've got here that's going to pop up in a second. So you'd still be able to use this as an option. So, all right. If we go to the calc, what are we going to do? Well, basically, we're going to do the same thing we did with the table, but we're going to let the calculator do all the calculating. So here's how this would work. We're going to type the expression into y equals. So once we get the calculator on, we'll go to y equals. If anything else is in there, we're going to clear it out. So for instance, here I see x plus 3. For those of you, it's been a while, next to alpha is this button xt theta n. That's your x. This guy right here. So x plus 3. And I'm not going to hit graph because I don't care about the picture. I want the values. So once I've done that, I'm going to hit second and graph. That's going to get me the table. So second and graph. And I get this table. And you're like, okay, so what do I do with the table? Here's what we're going to do with the table. And I'm just going to write it this time so you can see what I'm up to. What value are we going to start at for x? 0. Okay, so when we're at 0, the y value is 3. They tell me it's right there, 0, 3. And it's going to be a closed dot. So x is less than 0. What should be the next numbers I'm looking up? If we're at 0 and we want to go less, -1 and -2. So -1, 2, -2, 1. That's enough. 0, 3, close dot, -1, 2, -2, 1. Connect the dots. So basically, it's the table thing all over again, except now I'm not figuring out the values. I'm letting the calculator do it. It's fine. I still like the table or the other version better, but that's okay. And then I'm going to do it one more time with 2x. So I'd go back to y equals. I'd clear that out, maybe. There it goes. 2x. Second graph. Now, I'm going to start at 0 again. So I see 0, 0. That's going to be an open dot. But am I going to use -1 and -2 again? No. What am I going to use instead? 1 and 2, because I'm going to the right now. So 1 is 2, and 2 would give me 4. So 0, 0, open dot. 1, 2, 2, 4. Connect the dots. Calculator version. Don't care which one you use, but we gotta keep playing with these. Gotta keep playing. The assignment for this, because this is your note sheet, the assignment for this is down at the bottom. The first chunk of them, I believe, yeah, the 13 through 20 is the algebra type ones, where you plug in a value. And then the last 4 are graphing ones. That's what you got the graph paper for. So personally, what I would do, hopefully if I have my book, is I'd just jot down at least the graph problems, because then you've got this to look at. You won't even need the book for later. But otherwise, I try to knock this stuff out. I mean, 15 minutes? Shoot. You could at least get that part done. I'm serious. That part done, just jot those problems down in no book. Now, if you don't have a book, you're going to have to be like somebody's friend. Be like, hey, how's it going? Can I check that out too? And kind of go that route. So try those out. We'll be doing more of this on Monday.